Okay, so in this video what I want to talk about is Ohm's Law. And what Ohm's Law basically does is it explains the relationship between voltage, current and resistance, okay? And how that can be expressed in terms of an equation is voltage equals current by resistance. Okay. And now we also know, when I discussed about the triangle as well, an easy way of remembering it also. So in this, obviously V stands for voltage, I for current, and R for resistance, okay? We have V at the top. Then we have our I for current and R for resistance. Okay, and I gave the explanation that if I was to cover V here, if we wanted V, I'd cover that, and then that would obviously be current by resistance. If I wanted resistance, it'd obviously be V over I, and vice versa, whatever way we want it. Remember that current is measured in amperage, and then resistance is obviously in ohms, okay? So that's just the basics of Ohm's Law starting off. So what I want to do is just draw out a circuit here. So it may be a little bit messy, so just bear with me now as I draw it out. Okay, so apologies for a very poorly drawn circuit here, but it's a bit tricky at times trying to draw on the screen with these pens. So I just want to label everything here. So I'm going to have a resistor here of 4 ohms, okay? This is obviously my switch here. And this is my battery, my very poorly drawn battery symbol, and that's going to be 12 volts, okay, in this circuit. So obviously this, again, I might rub out my question mark here because it looks like a 2 nearly. Now, we have our resistance, we have our volts, but the one thing we don't have is our current. We don't know what the current is. So let's just go back over to our diagram here. And we obviously have voltage, which is 12 volts. Our resistance is 4 ohms, and we don't have our current. So how are we going to calculate this? Well, it's quite simple, isn't it? So it's going to be current equals voltage over resistance, okay? So let me come back over. I've covered the I, I've covered this I, voltage over resistance. That's what I was left with. Therefore, I equals 12 volts over our 4 ohms. I is going to equal 3 amps. Okay, very simple. I know the last time we were doing it, it was a bit confusing getting the correct units, but if I'm given this in an exam, I'm going to have it simple enough that we're not having to break down our units. So this is obviously 3 amps then. So let's just say, for argument's sake, we were given the resistance and then we were also given the current, but we had to find the voltage. So what would we do in that case? So we'd cover our V, and it would therefore be current multiplied by resistance. So let's write that out for example. So V equals I by R. V is going to equal, we just found it out, it's 3 amps. So I'll write 3A by our resistance, which is 4 ohms. So remember that sort of horseshoe symbol. Again, that's poorly drawn. So volts equals 12. So we know we're correct there. Now if we want to double check it even more, and we weren't given the resistance, let's say. So let's go back to my triangle here. We want to find resistance, therefore we're left with V and I. V is over I, so therefore that's how we're going to do it. So let's write it over here. R equals V over I, which is R equals 12 volts by 3 amps. R equals 4 ohms. Okay, so those were 3 calculations there, and I was able to find the voltage, the current, and the resistance of this very poorly drawn circuit. Okay, so basically when you have 2, if you have resistance, you have current, you're able to find voltage. If you have voltage and resistance, as we had, you're able to find current, and vice versa. So if you have 2, you're always able to find the other. I keep recommending every time I went back to the triangle and use this formula that if you're trying to find volts, cover the V, I by R. If you're trying to find resistance, cover the R, V over I, and that's the easiest way I find it. Okay, I find remembering to do this sum. Okay, thanks very much.